complicated with fractional exponents and negative exponents and all sorts. But let's practice with a simple, any function that you want to give me. Any function at the top, any function in the denominator. Something simple. Anyone?
4x squared plus 2 on top.
Excellent.
Let's do 6x squared minus 4.
Minus 4x. Okay, perfect. Good. I have to follow this pattern. Don't try anything. This is the rule. We have to follow that rule. I immediately copy the denominator and square it. Then I differentiate the top. Can anyone give us the derivative of the top? So this will be here.
8x.
Excellent. I copy the denominator, 6x squared minus 4x. I'm here with minus. I copy the top. Can anyone differentiate the denominator? And I'll put it here.
12x minus 4.
Excellent. Thank you very much. Good. All I have to do not, careful. First of all, we never expand the denominator. The factors in the denominator, don't touch that. Secondly, please, you can look here and say, oh, I can simplify one from here with one from here. No, that's not possible, because this is not a factor here. Notice that there is a minus. You cannot simplify. So what we have to do is distribute, combine like terms. So the denominator is 6x squared minus 4x squared, carved in stone. Do not even look at it. Okay? Distribute 48x to the third minus 16x squared minus. So I have 4x squared times 12x, that is 48x cubed. Then I have negative but with minus in front, so positive 16x squared. And then 24x with minus. And then negative 8 with minus in front. And now I continue. Luckily, look at that. Look at that. So the numerator is negative 24x plus 8 over 6x squared minus 4x squared. I hope you understand that we're not going to do this with the limit of the difference quotient, right, when h approaches 0. No, it will take me the whole day. So we are using the differentiation rule. But this is the definition of the derivative. But no, we're moved on from that. We can apply the product rule or the quotient rule that we just applied. Okay, one more concept here that I want to emphasize. And then I'll let you pick any problem you want. And we have to look at word problems so you understand why we're doing this. Okay, so remember we looked at cost function. Okay. If we want to find C prime, the rate of change of cost with respect to time or whatever, number of units, whatever, this has a different name. Yes, it's the derivative. Of C of x, but it's also called marginal cost. That's its name. We also have something called C of x that is divided by x. This is the average cost. It's a function. It's the average cost. So this is a new function, a totally new function. Normally is denoted by C prime with a bar on top of it, but it's not important. So just remember, if we are talking about the average cost, then we are looking at C of x divided by x. So this is valid for or the same idea is if I have profit. If this is profit, this is P of X, P prime of X will be marginal profit. And P with a bar, which is P of X over X, will be the average profit. I can have revenue. So all these are valid for revenue and also profit. Of course, the notation is different. So if I'm looking at revenue, then R of X is the revenue function. R prime of X will be the marginal revenue. And R of X over X will be the average revenue. So please understand these concepts. This is the function. The marginal cost is its derivative. And this ratio, C of X over X, is the average cost or revenue or profit. Okay, I'm going to share my screen. I thought I had that up already. Oh no, I don't need that. I need 1.7 and I'll go back. It's on, we are on page 162. So we want to practice the product rule, the quotient rule, and look at word problems. Unless I'm logged out. I hope I'm not. Okay. 162. It's still open whenever it wanted it to open. That's okay. So yes, something like this we have to look at also. We'll see in a moment. Okay, so we can choose anything you like for product. We can choose anything, or even from here, or quotient, or a product or quotient from 21 through 48. Now, I shouldn't apologize to you, but I guess because it's not my fault, but I will apologize. Of course, this makes no sense. They're giving the cost. Oh, they're giving the revenue. They're also giving. Okay, sometimes we do find mistakes in this book, but okay, this time it's not a mistake because they're giving us the cost. I didn't see this. Sometimes they write average profit, but then they give the cost and don't give the revenue. But now in this case, it's okay. Good. Okay. So are we going to pick, or I will?
Can we do number 13?
Yes. Let's take a look at 13. Let's take a look at 13. Where is it? 13. Yes. So in 13, we have y equals x to the 7th divided by x to the 3rd. Perfect. Always remember, when we are faced with any problem, and we are asked to find y prime, so find y prime. Always remember factor and simplify. I will never use the quotient rule on this because I copy the base, and what operation do I perform with 7 and 3?
Subtraction.
Yes, 7 minus 3 is 4, and when I differentiate, I'm done. So always try to make your life easier. If you can simplify, always do it. If you simplify only after you factor, then first factor and then simplify. Do whatever needs to be done to make your life easier. And it was a very good pick. This discussion was really important. Thank you. Okay, anything else from product or quotient? Anyone else would like to pick?
15.
I couldn't hear you.
16.
16, very good. Let's take a look at 16. Another very good pick, and you'll see in a moment why. So we're given f of x equals 2x to the 5th plus x squared over x. Awesome. Awesome. You're helping me go through what I really needed. Good. So again, if the denominator is only one term, so notice a few minutes ago, you picked this problem for me, but the denominator did not have one term. The denominator has two terms. With this problem, I could have never done what I'm going to do with 16 because the denominator has two terms. Okay. But what I'm going to do with one term, always simplify if possible. I'm going to separate it in two fractions because of this one term. When I have one term, I can separate into 2x to the 5th over x plus x squared over x, only because this is one term. And now again, I'm back. 2x to the 5th over x. Can anyone give us the simplified form? Anyone I haven't heard from, like Nathan and Brianna and Cameron. Yes, Cameron, if you want to. Yes.
10x to the 4th.
2x to the 4th. Awesome. And
2x.
so
It's going to be just plus x.
very good, because we copy the base and we subtract the exponents. 2 minus 1 is 1. Good. This is what I want to differentiate. I'm not going to differentiate this because I made it so much easier. So can anyone now tell us what is f prime equal to? What does it equal to? Brianna, are you with us? You want to try? I guess Brianna is not with us. Sean, do you want?
Is it the 2x
Yes.
to the 4? No.
We bring down the power. When I bring down the power, I have to multiply by 2. How much is 4 times 2?
8.
Good. Times. I subtract 1 from the power.
3.
But I have to write x, right?
Yeah.
Good. Okay. Plus, I differentiate x. What do I get? It's the same rule. Power 1. Bring down 1 and subtract 1 from the power. How much is 1 minus 1?
0.
And how much is x to power 0?
1.
Exactly. That's why we only get 1. That's why the derivative of x is 1. Or the slope of x. The slope of x is 1. Good. Good pick. Both of them were very good. Thank you, Yulia. Good. Anything else we want to pick from here? Let's move on to the next set. Anyone?
Could we do 35?
Yes. Let's copy 35. 35, and this is on page 163. We have f of t equals t plus 2 over t and times t squared minus 3. Awesome. So this is a product, and then we should choose also from a quotient, and then we'll look at word problems. Perfect. Awesome. So this is function 1, and this is function 2, because this is a product. If there is no symbol between parentheses, then I know it's a product. So we're going to use the product rule. So f prime of t. I have to differentiate the first function. Let's take it easy. How much is t prime? We just wrote it 3 times. This is the 3rd time today.
1.
Excellent. Now please remember what we did last time. The constant stays in front. what was 1 over t or 1 over x equal to?
Negative 1 over x squared.
Excellent. So 1 over t, or even 2 over t, doesn't matter. 2 goes in, stays outside anyway. So 1 over t prime is negative 1 over t squared. Who was that? Thank you very much. This is very important to remember. Good. So minus 2 over t squared. Because 1 over t prime, we developed this together last time, developed it together, we found the result together step by step is negative 1 over t squared. The product rule says now copy the second function. I'm copying it. Then says plus. Now it says copy the first function. And now it says differentiate the second function. Can anyone differentiate this for us? Brianna, are you with us? Okay.
She said in the chat that she had strep throat and she doesn't have a voice right now.
Okay. So just give us the answer. What is t squared minus 3? Can you type it for us? Thank you so much because I didn't notice that. Awesome. Brilliant. Thank you very much. Great job. So yes, I should not leave it as is. I should distribute. Let's see what we get. 1 distributed to t squared. 1 distributed to negative 3. Negative 2t squared distributed to t squared. The t squared goes away. Minus 2. Negative 2 over t squared times negative 3 is positive 6 over t squared. This is 3 over 1. 2 over t squared times 3 over 1. 6 over t squared. This times this plus 2t squared. This times this, the t's will go away, plus 4. So then I have t squared with 2t squared. I have plus 6 over t squared minus 5 plus 4, negative 1. Done. So we applied the product rule. Let me refresh our memory on the product rule again. So function 1 times function 2 prime is function 1 prime times 2 plus function 1 times function 2 prime. Awesome. Great job. Okay, so let's look at a quotient. Good pick. Very good pick. Thank you. So let's choose a quotient. Okay, this will take us too long. Let's choose something like with not with 3 terms. That's just endurance. It's not really giving us anything more. Yeah, I would like to look at 43. Allow me to choose 43. F of t equals 1 over t minus 4. Remember what we said, always factor and simplify. Do I want to use the quotient when the numerator is a constant? No. I want to change it into, we cannot change it into till I explain the chain rule though. Sorry. So I cannot change it right now. I'll show you later. Okay, so in that case, let's differentiate. Remember, let me refresh your memory on the difference on the quotient prime. Same thing as the product with minus though. 1 prime times 2 minus 1 times 2 prime over the denominator squared, not differentiated. So that's fine. That's exactly what I want to start with. I want to start with this. Now, step by step, fill in all these pieces. First function prime, the top. Can anyone give us the derivative of this?
0.
Yes. So in this particular case, only in this case, this term is gone. Thank you very much. So then I copy minus. I copy the first function. I don't have to. It's just 1. And now I need to differentiate the denominator. Can anyone give us the derivative of this? This is the 4th time today.
-3.
The derivative of t minus 4. Let's try again.
-1.
Yes, because there is negative here, but this will be 1. Excellent. That's it. Done. You can rewrite it as -1 over t minus 4 squared. But this is it.